Okay, in 16, there's a parabola that's been shifted right 2 and up 1. So that one's pretty easy to do. With the other graph, I had to make a table and plot a few points before I felt comfortable about what it looked like. But it was roughly something like this. And then x equals 1. And then x equals e. So remember, e is about 2.7. So it doesn't have to be a super accurate graph, but enough to see that the parabola is always on top and this natural log function is always on bottom. So I know I can integrate top minus bottom dx from 1 to e, and the one on top is that, the one on bottom is this. And then again, we're stuck with, if we have a calculator, we can get it to do it for us very quickly. If we don't have a calculator, I'd recommend that you actually FOIL this out. Change this to x squared minus 4x plus 4, and then undo power rule 1, 2, 3 times if you combine it with this. But then to integrate this, you're going to have to use u substitution. If you pick natural log of x to be your u, then du would be 1 over x dx. So that would be a perfect fit. But either way you do that, this is the last question, so that gives us a little bit of a hint. It would give you the one on the front page that we started with. Of course, if you use a calculator, you're going to get a decimal only. So I guess you would need to at least compare it with that. But main thing you need to get out of all these is some practice of sketching. Realize you need to know which one's on top or which one's on bottom. If the same one's not always on top and the same one's not always on bottom, you might consider right minus left instead. Sometimes the bounds are given to you, like in number 16. They basically told me it was 1 and e, but sometimes you need to find the intersection. So set the functions equal to each other, and I don't know, I feel like that summarized all the questions quite a bit. Some of them had some unit circle stuff. Some of them you didn't need calculus on. Quite a few parabolas. But anything more detailed about 16 while it's up there?